Welcome to AMD's virtual booth at the 2021 Rice Oil and Gas High Performance Computing Conference. I am Derek Boyas, Product Manager for Accelerated Compute, and today I will introduce you to some of AMD's new technologies to accelerate your discoveries. You're going to hear about some of AMD's products and technologies that are planned for the future in this presentation that are based on our expectations as of today's date and involve risks and uncertainties that could differ materially from our current expectations as set out here in our cautionary statement. We are meeting virtually today because of COVID-19 and its impact on the world. AMD has been sponsoring an HPC Fund with the donation of AMD Epic processors and Radeon Instinct accelerators to assist in COVID-19 research. 21 research institutions and universities are actively using this hardware, both on-premise and in the cloud, to find ways to stop this virus. Workloads that rely on high-performance computing are diversified, from scientific research to commercial applications to big data analytics and AI. And AMD Epic processors and Instinct accelerators address the needs of users across different types of workloads or customer use cases and verticals. AMD is focused on product development that targets and accelerates the most demanding workloads. And why? The high-performance compute is driven by 50+ billion devices generating a sea of data. The time to market or time to value as a competitive advantage, solving these business problems. High-performance compute generates actionable intelligence in life sciences, for product innovation, or even understanding shopping habits that create custom marketing programs. All of these can be utilizing AI and machine learning. AMD Epic processors are purposely built for this new hardware and emerging use cases and services. In 2019, we launched our second generation Epic processor, and we're starting to see a huge momentum shift with customers. 5 years ago, the Intersect 360 research study showed 36% of HPC users had a favorable forward-looking impression of AMD CPUs. In a similar study last year, that percentage had more than doubled to 78%, overtaking the competition. AMD has the perception and performance crowns with the second generation AMD Epic. The Epic is the best-in-class performance, mostly from the balanced architecture. No matter what core count you choose, we provide customers the same features and functions with no additional price. 128 lanes of PCI Gen 4 for the industry's highest I/O bandwidth, support for up to 4 terabytes of memory per socket, and 8 memory channels per CPU for the best-in-class bandwidth. So all of this with the AMD performance, the execution in the roadmaps, and listening to our customers equals a strong partnership. And you may have heard that our community of users have kicked off a worldwide AMD HPC user forum to collaborate with each other and ensure success with their workloads. There's another one coming up in April. On the path to Exascale, there are 3 distinct phases of computing in HPC in the past 2 decades. There's terascale computing, where systems delivered teraflops of performance were driven by CPUs. But the CPUs couldn't deliver the efficiency required for petascale, and GPU computing was discovered. However, those GPUs were general-purpose GPUs doing a broad range of workloads like rendering, graphics, as well as compute. And today, we're at the heels of the era of exascale computing. To drive to exascale, we're going to need a different type of GPU. AMD's differentiated strategy is that a compute-optimized architecture, not a general-purpose architecture for the GPU, will get us to that exascale level. At SC20, we announced the AMD Instinct MI100 GPU, the world's fastest HPC GPU. It is the first data center GPU ever to surpass the 10 teraflop barrier for FMA 64-bit operations. For FP32 matrix operations, key for HPC and AI workloads, it delivers 3.5 times faster performance than the previous generation, the Radeon Instinct MI50. Many AI workloads are investigating mixed precision and FP16 precision formats. And here, the MI100 provides nearly 7 times the performance of the previous generation. To put the performance of MI100 in perspective, look at the specs of the #1 supercomputer 20 years ago, ASCII White. This machine broke into the supercomputing scene and was the first to break the 10 teraflop barrier. The entire system delivered a peak of 12.3 teraflops. 20 years later, a single GPU, MI100 at 300 watts, delivers 11.5 teraflops peak. All of the 6 megawatts of performance is contained in a single GPU. It's quite amazing. As you may recall from the path to Exascale chart, I pointed out that GPU performance gains are threatening to slow down because GPUs are addressing an ever-broadening spectrum of workloads, and thus carrying more and more function and complexity, which makes it harder and more difficult to deliver performance. AMD is addressing this crisis with our introduction of the CDNA architecture. We bifurcated the GPU family into 2 purpose-optimized chip architectures, RDNA and CDNA. This split has freed our design team to focus on each of these 2 very important tasks, gaming and HPC. These workloads run on different systems, so separating them into 2 product and chip families is a great way for us to design better products for our customers. MI100 is the first GPU ever from AMD to be built on the CDNA architecture. CDNA is our compute-optimized architecture. This is the base architecture that will power the Frontier system at Oakridge and the El Capitan system at Lawrence Livermore. The performance optimizations that this new architecture has enabled can be seen by some of the tremendous generation-to-generation step function improvements that MI100 has made. CDNA has twice the number of compute cores versus prior generations. This is what gives us our leadership peak performance. It also offers an all-new matrix core technology, which packs multiple matrix operations in a single cycle for high throughput. Matrix core technology enables us to deliver almost 7 times the performance improvement with FP16 and FBFloat16 operations, which are so important to AI workloads. As HPC and AI problem sizes increase at a tremendous rate, we've also improved our GPU-to-GPU performance with our Infinity architecture by over 4 times of our previous generation. And finally, we have also improved the HBM memory bandwidth by 20% using the same HBM2 technology, but running it more efficiently. As you can imagine, Oakridge, our first Exascale client, has been very eager to take our MI100 for a test drive. They are running some of the Exascale applications as part of Oakridge Center for Accelerated Applications program, and it's been quite a success. AMD has seen about a 3 times performance boost over their current hardware in the Summit supercomputer. Chola, the astrophysics simulation code, is seeing another 40% better performance versus V100. Picon GPU, an application to simulate laser therapies, is seeing 40% faster performance compared to our prior gen product. And Jess, a turbulence code, is seeing 2.6 times faster performance versus V100 in a similar setup. So now switching to software. Convincing you all in the world that AMD has produced a great GPU is probably the easiest task. It is well established AMD is a great HPC processor company, and I'm sure most of the watchers of the GPU industry are now thinking, what about the software? Where is someone going to get software to run on these great GPUs? AMD ROCm is the software platform for our GPUs, and its adoption has been growing because it's open source and enables an easy way to port existing CUDA code applications to HIP and the AMD ROCm platform. A few examples are HACK, the astrophysics code, which runs on some of the world's largest supercomputers, was ported in just an afternoon. SpecFem3D, an earthquake simulation code from Europe, which runs at large scale, was ported in just a day. And CUDA, the core library for some of the most popular quantum physics codes like Chroma and Milk, which is one of the most complex CUDA code bases, was ported in 21 days. And a final example, in Chola, the Exascale application at Oakridge was ported in just an afternoon. And the list of applications, frameworks, and libraries keeps growing. Of course, just porting and running code is not what we are about. It must perform. One of the key features of ROCm 4.0 is that it's optimized for MI100. When looking at the end benefit to customers, they are getting 8 times the performance improvements in just 2 years over previous generation of platforms. This is the power of software and hardware being optimized together to deliver greater than Moore's Law performance gains. And today, we're announcing ROCm 4.0, our 4th generation of the ROCm software stack to go along with MI100. 2 years ago, when we started working with HPC partners, we defined the stack that would help drive Exascale in production, so we built the foundation. In 2019, we filled much of the technology stack with machine learning optimized software. With ROCm 4.0, we're delivering a software stack ready for large-scale deployments. From workload management tools, to frameworks, to programming language support like OpenMP and HIP, it's now optimized and ready for customer engagements. As we close, we're excited to be delivering MI100 and see what our customers will do with ROCm in the open ecosystem. Some of the early users have had tremendous results and are very excited. Bronson at Oakridge is obsessed with the fact that ROCm open software platform and HIP developer tools are open source and work on a variety of platforms. Evan's experience confirms how quickly an application can just work in an afternoon. And finally, the Posi team had a great experience porting and optimizing their applications and have seen a significant performance uplift on AMD Instinct MI100. So where can you get an AMD system to try for your compute-intensive RTM code or AI workloads? We are working closely with 4 large partners who have been driving hard to get MI100 into customer hands as quickly as possible. Each of the system vendors shown here will be shipping an all-AMD solution with AMD Epic and AMD Instinct MI100. These powered systems are available now, and check with your vendors for the specific ordering details. So thank you for attending our virtual booth at the Rice Oil and Gas Conference. We hope you have a great day.